what we're going to do is to make use of two different functions. Okay, we're going to make use of two different functions. We want to call that test set check and then split string test by ID. The library ziplib, its basic functionality in here is to help us do data compression. And then from the library ziplib, we have the function crc32, which it is a type of a hash function used to detect errors in data storage and then transmission. Because in this case, we are going to compress data, we want to be 100% sure that there are consistencies in the values after the hashing. Okay, so the hashing actually, in this sense, is done on this line. All right, and then we want to state that all of the hash values, those that are less than 20%, of the maximum hash value, which in this case we are representing as 2 raised to the power 32, all should be considered as what? As an instance to be moved into the test set, which will logically mean that all that will be equal to 20% or greater than the 20%, greater than or equal to the 20% maximum hash value will be moved into the train set. This will help us to have that consistency of values in the test set and then in the train set. All right, so in the function split train test by ID, that the splitting in this case is going to be done purely based on what? Based on the ID. All right, let's run this. And then what we're going to do now is to call the method split train test by ID, and then we pass on a house. Before we do that, let's create this variable that will help us to add the index column. Okay, to add the index column, because we don't really have a unique identifier. Okay, so we want to add this to the number of we want to add this to the instance. We want to add this to the columns in the existing data set. Okay, so we call this housing with ID. Okay, that is not going to suggest that we have entirely a new data set, but to the earlier content of the data set, all we are going to include now is just what? The ID field. Okay, so to do that, we mention housing dot reset underscore index. So this is just to create a new column. We will call that what? Index. Okay, so further on, we want to now call this method to do the split over here, and then we pass on our data set. We want to call this housing with ID, and then we'll still retain that the splitting is supposed to be 0.2, and the name of the column we want to create, we want to call that what? We want to call that index. Right, we should add that to the existing columns. All right, so this will return, we're expecting this to return the train set and then the test set. Now, if we go by this approach, although what we have done in this case now, it is going to work 100%, but if you use the row index as a unique identifier, then it will mean you would need to make sure that the new data gets appended to the end of the data set, and no row ever gets deleted. Right? No one will have to delete any data further within the data set, because it is following a straight sequence of data. If this is not possible, then you can try to use the most stable features within the data set. And I think in the case of the data set that we have, That which will be more stable will be the longitude and the latitude. The rest of it may be changing very much often. Now, to simplify issues, in the API scikit-learn, it provides some few functions that we can use to split data set into multiple subsets in various ways. Okay, quickly to check out that, we can look at doing that using the sklearn dot model selection. We want to import the library, import the function called train test set. We have used it before in the earlier example where we were trying to create a model for a model that will help us predict the genre of music and then to make that recommendation. If you have not watched that yet, you can go to that video and then quickly watch that. Right. So in this case, the function train test split will help us to do the splitting without us having to write our own function. Okay. So what we will do is to create an instance of this method, a train test split, and then also with this same function in sklearn, we pass on housing, we pass on the test size, which is supposed to be 0.2, and then we will say that the random state is supposed to be what? 42, which will mean that all the time you're going to have a fixed set of rows to be picked from the data set. So then even if you run the code over and over and over and over again, it will not get to change the rows that to be selected from, to form the data set, to form the test set and then the train set. They would all the time be uniquely different from each other, and then they would be the same. I should think I didn't put it well. What I mean is, for all the instances that we put into the test set, they will remain the same throughout the execution of the program. They will not change as we keep running the program. Okay, so let's quickly run this to see. Right, so this has done the splitting for us using the train test split function. If appropriately, sorry, I have missed out one thing because it's not supposed to print. I have missed out the equal to symbol here, because this is supposed to return, this is supposed to return both the training and then the test set. So we say this should be equal to the train set, train underscore set, and then the test set. So then when the method is called, it will pass on those records into this. This should be set. All right, this must be correct. Great. So the train set is available in this, the test set is available in this. Let's just be 100% sure if we are doing the right thing. Let's print out the content of the train set and then see. Okay, so it tells us that we have 16,512. Okay, so that is correct. That is the 80%, and then let's see the 20% for the test set. All right, so that shows 4128 number of rows. That's correct. So in this case, it has been splitted into the train test split. So we can choose to create our own function in doing the split, or we can use it as it is provided from sklearn. And then in this case, to make sure that we don't have this randomization, then we will need to state the random state, put it to effects. that, let's say, for example, the randomization should be done at a phase on 42 instances, a random state seed of 42, right? So all the time we are 100% sure that we're going to have the same set in the test, even if we run it over and over and over again. All right, so we will still have to continue in trying to make an attempt of finishing the pre-processing section of this particular project. Right, so now let's assume that you have had a chat with experts who told you that the median income is very important attribute to predict the median housing prices. If that is true, then you may want to ensure that the test set is a representative, is a good representation of the various categories in the income's whole data set, right? Since the median income is a continuous numerical data by inspection, right? If you inspect the values, you tend to understand that the median income is a continuous numerical attribute. We will first need to create an income category attribute. We need to create an income category attribute. So then now the split will be based not just on the ID, but now on the income the income category attribute that we want to create. The earlier on, the reason why we use the ID was to help us to have a fixed set of records that will be in the test set all the time. So then the model should not have seen those records before the testing stage. Okay, what must be used for training must be seen only at the time of training. What must be used for testing must be seen only at the time of testing. That was the essence of having to hash the row ID. But in this case, we are looking at the assumption that the median income, according to experts, is a very good attribute to consider to predict appropriately well the median housing price. If that is true, then we will need to remodel our data, so then it will give us a good data representation of the income, the median income within of the test set. All right, so quickly the question is, how do we do that? We would need to, as it were, now quickly look at the distribution of values in the median income. What is the median income? This is the median income. By inspection, you can see that majority of the groups fall between somewhere around of 1.5 through till somewhere and 6.5, and then a bit disjointed. Okay, so to do this, we want to create a categorical data to represent this. How do we do this? We use PD, the function pd.cut, that will help us to create this additional feature and then add it to the existing data set. And then we make reference to the data set, and then we say we want to make reference actually to the median income column. And then we want to specify the distribution of values. By the distribution, that is what we just looked at. We saw that the values were ranging more between 1.5 and then 6.0, and then slightly beyond of 6.0. Okay, so by this, the attribute bins will help us to do this distribution. To say that you should look at the range from 0 to 1.5, and then 3.0 to 4.5, and then from 4.5 to, let's say, 6.0. And then, like we mentioned earlier on, there is slightly some other values that come after 6. So this is median income. So from 1.5, more of the people fall within 1.5, but the majority fall within 1.5 and then 6.5. But you can see there is a little bit stretch even beyond of 6.0. Okay, that is why we're making reference to it as even be infinity. Okay, we want to house, when we call this method, it should pass on its result into housing income underscore category. All right, so by this we have created a categorization or categorical data column, and then we want to call that income category. The essence of this is to now do a distribution or reordering of the content of the data based on what the income category that we have created here. By the bins we have specified, it means that the distribution should be done on the fact that we have people whose income fall between 0 to 1.5, from 1.5 to 3.0, 3.0 to 4.5, and then 6.0 to some infinite defined what numbers. Okay, so that forms our categorical data, and then we are going to do the distribution of the records or the instances of the records within the data set to fall around of the range that we have created here. Okay, so let's see this in a pictorial view, and then we can better appreciate this, right? Let's try to plot a histogram to see how this distribution is. The histogram we want to plot, this is supposed to be a square bracket. We want it to be just on the income category. We want to see how the range of distributions are made on the graph. We call that instant cut, and then we want to plot the graph only on this. You realize earlier on we were plotting the graph on the total on all of the numerical fields in the data set. But in this case, where you want to pick just one, then this is the approach. You would have to call the name of the column you want to draw your histogram on, and then you call the function to plot the histogram. So we expect that this will show only the distribution for the income category based on the distribution we have indicated here. All right, we have an error. Let's get to see exactly what error we have here. On orderable types interval, less than float. Let's see. All right, so let's look at the distribution. That is correct. That is correct because I did not state the labels that should be given to it. So let's give it labels in here, so then it can get the right distribution. The maximum span is it should have 5 categories to be put around 1, 2, 3, 4, and then what? And then 5. So that will be the number of categories that we have created from 0 to 1.5. That is 1. 1.5 to 3.0. That is 2. 3.0 to 4.5, that is 3, 4.5 to 6, that is 4, and then 6 to the infinite set of values. So we have 5 different categorical data in here. Okay, so now we have resolved that. We have the graph well plotted for us. So we show the distribution from 1.02 to what? 2 to 5. All right. So this is telling us that the median income distribution in here, and then the maximum, the maximum is slightly above of what? 7,000 USD. Okay. So whilst we have done this, we are now ready to do a stratified sampling based on what? Based on the income category. And for this, we can go ahead and use the scikit-learn's stratified shuffle split class, which will help us to do this stratification or sampling stratification. All right. So let's look at how that will be done. We are using the sklearn model selection, and then our major focus in here is to use the stratified shuffle split. Okay, so in this case, it is the number of splits we have specified, it's just 1, and then the test size is still remaining 20%, and then the random state we have put is what? Is 42. All right, so we're saying that given the data set, it should base on the income category to help us have a new set of the train set, and then what? The test set. So the splitting is in this case done based on what? Done based on the income category. Okay, no more on the ID. Why are we doing this? We are doing this because our focus is on the fact that by the expert advice, the income category is a very much important field that will help us to predict very well the median house price. And that is why in this case we are ignoring the splitting of the train set and then the test set using what? Using the ID, but in this case we are using what? The income category. So on this line we are using the train index, which is the 80%, and we capture that and then store it in the stratified train set, and then the rest of the data will be considered as what? The 20% for the test set. Okay, let's see the distribution, how it is done. How is the distribution done? Let's see. If we run this, we tend to understand that for the categorizations of values from 1, 2, 3, 4, 5 as the categorical data, in all of this, their relevance or the average values fall between, in the case of 3 is 0.35, in the case of 2 is 0.31, and then we can see also that for 4, 5, and then what? And then 1. So whilst this has helped us to do the split based on the income categorization, we will need to remove the income category because it is not a major field that we want to consider in doing the prediction, although it is relevant. But its relevance was to help us to have a very good distribution of what? The data in each representation within of the split of the test, and then what? And then the train data sets. So how do we remove it? To remove this, we will want to use the function. We call the function drop to help us remove that. Okay, so in the strat train set and then that of the test set, we want to pick the column in which is labeled as income cut, as we created here at the top. We created it here. We would want to remove that, okay? And then we have put in the parameter attribute as true, okay? If it is set to false, means that we will not want to remove it or we will not want to drop it. But whilst it is set to true, that will help us to remove it from the earlier column that we had created or we had introduced, okay? So by this activity we have done, we have come to appreciate how to do the splitting of data set. So then consistently we can have some consistent number of instances within of the test set and then within of what? Of the train set. In most cases, because of the amount of work that is involved in this section, a lot of machine learning engineers will ignore this side. However, it is very much important because it is going to influence the performance of what? Of the learning algorithm, the predictions that it is going to do. Right? So the next thing we'll be looking at after we have done this is to discover and then visualize some data gain insights within of the data to help us to better understand the data before we pass it on to what? To the learning algorithm. And if you did like this video presentation, click on the like button. Or if you have any questions also, you can write your questions in the comment panel. I'll make time and then give responses. Thank you so much.